Assalamualaikum and good morning everyone. So today we have come to the last subtopic for chapter 4, which is the applications of indices, surds and logarithms. So this is the learning standard for today. By the end of this class, you should be able to solve problems involving indices, surds and logarithms. So these are the flows of today's class. First, we will look at example 35 from page 122 in textbooks. Secondly, we will do two questions from self-practice 4.14. Thirdly, we will do two questions from mastery practice. And lastly, you will do some exercise in textbook page 123, which is from intensive practice 4.4.
Okay, let's look at the first example, which is example 35 on page 122 in textbooks. An entomologist found that a grasshopper infestation towards plants spreads across an area of A of n is equal to 1000 times width 2 to the power of 0.2 n acres, where n is the number of weeks after the initial observation. So A, determine the area of infestation at the beginning. B, determine the area of infestation after 5 weeks and also 10 weeks. C, how much time is needed for the infestation to spread across an area of 8,000 acres. So the solution for the first one, we write down the equation function, which is A is equal to 1000 times with 2 to the power of 0.2 n. And when it says at the beginning, that means n is equal to 0. So we substitute 0 into n, and we will get area is equal to 1000 acres. For question B1, we want to determine the area of infestation after 5 weeks. So what we do is, we substitute the value of 5 into n, and we will get area is equal to 2000 acres. And for B2, we substitute the value of 10 because we want to find the area for after 10 weeks, and we will get 4000 acres. Okay, for question C, we would like to find how much time is needed for the infestation to spread across an area of 8,000 acres. So what we do is, we write the equation function, which is A is equal to 1000 times with 2 to the power of 0.2 n. Then we substitute the value of A, which is 8,000 acres, is equal to 1000 times with 2 to the power of 0.2 n. And when we bring the 1000 here, we can divide 8000 divided by 1000 will give 8 as the answer. So 8 is equal to 2 to the power of 0.2 n. And how to solve this? How to solve this equation? We can equate the base. If the bases are equal, then we can compare the index. So we change 8 to be 2 to the power of 3, and then we write 2 to the power of 3 is equal to 2 to the power of 0.2 n. When the bases are equal, which is 2, so we can compare the index. 3 is also equals to 0.2 n. So we write 3 is equal to 0.2 n. So to get n, you just simply divided 3 by 0.2 and you will get n is equal to 15. Okay, now let's solve the first question from self-practice 4.14, page 123 in textbooks. A gardener observed a bug infestation towards plants in his garden. He finds out that the area of insect infestation towards his plant is A is equal to 1000 times with 2 to the power of 0.7 n acres, where n is the amount of weeks after the first week of initial observation. So, how long will it take for the insects to infest an area of 5000 hectares? Actually, this is not hectares. Please change to acres, because based on the answer at the back of your textbook, this is actually is acres. Just for your additional information, 1 hectare is equal to approximately 2.471 acres. Okay, but in this question we will use acres. Okay, to solve this, what we do is first we write the equation function, which is a is equal to 1000 times with 2 to the power of 0.7n. Then we substitute 5000 into the value of a. So 5000 is equal to 1000 times with 2 to the power of 0.7n. And we divide 5000 with 1000 and we will get 5. So 5 is equal to 2 to the power of 0.7 2 to the power of 0.7n. But for this equation, we cannot equate the base. So how to solve this? So the other way to solve this is we take log on both sides, left hand side and also right hand side. So we write log 5 is equal to log 2 to the power of 0.7n, and we take this to the front and it will become log 5 is equal to 0.7n times with log 2. To find this n, you can simply bring 0.7 and log 2 down. Log 5 divided by 0.7 times with log 2. And you will get n is equal to 3.317 weeks. This is approximately 3 weeks and 2 days. So you can just leave your answer in this form. Okay, question 2. The electric current that flows in an electrical circuit for t seconds after its switch is turned off is I is equal to 32 times 4 to the power of negative t amperes. So A, calculate the current flow when the switch is off. B1, calculate the current flow after 1 second, and also B2 after 2 seconds. And C, how long will it take for the current to reach 0.5 amperes? So the solution for A, we write I is equal to 32 times with 4 to the power of negative t, and we substitute t with 0 because when it says the switch is off, that means t at that time is equal to 0. So we substitute 0 here and we will get the current is equal to 32 amperes. For B1, simply substitute t with 1. So you will have I is equal to 32 times 4 to the power of negative 1. 4 to the power of negative 1 is equal to 1 over 4. So this is equal to negative 2 divided by 4 and we will get 8 amperes as the answer. For B2, substitute t is equal to 2. So you will have 32 times with 4 to the power of negative 2. And remember, 4 to the power of negative 2, negative means 1 over. And 4 to the power of 2 is what is down here. So we write 32 divided by 4 squared and we will get 2 amperes. For question C, how long will it take for the current to reach 0.5 amperes? So how to do this? First we write the function I is equal to 32 times 4 to the power of negative t, and we substitute the value of I with 0.5 amperes equal to 32 times with 4 to the power of negative t. We divided 0.5 with 32 and we will get 1 over 64. So we change the form of 4 to the power of negative t to 1 over 4 to the power of t. So by comparing both sides, 64 is equal to 4 to the power of t. We convert 64 to 4 cube because we want to compare the bases. Since the bases are equal, which is 4, then the index are also equal. So 3 is equal to t. So t is 3 seconds. Okay, now let's try question 6 from Mastery Practice on page 124. So it says the temperature of a type of metal decrease from 100 degrees Celsius to T degrees Celsius according to T is equal to 100 times with 0.9 to the power of X after X seconds. So calculate A, the temperature of the metal after 5 seconds. Okay, means X equal to 5. B. The time taken x in seconds for the temperature of the metal to decrease from 100 degrees Celsius to 80 degrees Celsius. Okay, so the solutions for A, we write the function t is equal to 100 times with 0.9 to the power of x, and we substitute x with 5 because it won after 5 seconds. Then we will get the temperature is equal to 59.05 degrees Celsius. For B, we want to know the time taken x when the metal temperature decreased to 80 degrees Celsius. So what we do is we substitute 80 degrees into T. So 80 degree at T is equal to 100 times with 0.9 to the power of x. We don't know the how long is the time taken yet. So what we do is we divided 80 by 100 and we will get 0.8. Then since we cannot compare the bases, so what we do is we take log on both right hand side and also left hand side. So we write log 0.8 is equal to log 0.9 to the power of x, and we bring this down to the front. So it will equal to log 0.8 is equal to x times with log 0.9. So to find this value of x, simply divide log 0.8 divided by log 0.9 and you will get x is equal to 2.12 seconds. Okay, question 7 from Mastery Practice as well. After n years, the price of a car that was bought by Raju is 60,000 times with 7 over 8 to the power of n. Determine the number of years for the price of the car to be below than 20,000 for the first time. So we write the equation function which is 60,000 times with 7 over 8 to the power of n, and since we want to know the number of years for the car price to be below 20, we write the less symbol. So less than 20,000, and we divided 20,000 by 60,000. That will give us 1 over 3. So 7 over 8 to the power of n is less than 1 over 3. So since we cannot compare the bases because the bases are different, so what we do is we take log on both right hand side and also left hand side. So log 7 over 8 to the power of n is less than log 1 over 3, and we bring down the power, the index n. So n times with log 7 over 8 is less than log 1 over 3. So to find this value of n, we can divide log 1 over 3 with log 7 over 8. But you must remember, log 7/8 is a negative value. So when you bring down and you divide a negative value, this symbol will change. This symbol will change. So it will become n is greater than log 1 over 3 divided by log 7 over 8. So n is greater than 8.2274, and since the question asks for the number of years, this must be integers. So the integers that is greater than 8.2 is 9. So the answer is 9 years. Okay, so here are the exercises. Please do intensive practice 4.4 in your textbooks. There's only 3 questions, and I have provided the answers in the next slides. So that's all for today. Thank you.